Okay, folks, so for today, we'll see a bit more about what's going on when exploring networks visually, what is the point, what's the problem behind, and we'll see some real-world applications about visual networks, what is really useful in the industry. We'll also see some advanced visualization techniques in Gephi, some tricks that may be very useful for the question you have. And, well, depending on the time we have, we'll follow the layouts tutorial, which is also available on the Gephi website. And I gave it to you in the course material yesterday. And for tonight, we'll continue some exercises in Gephi, using especially the Irish blogosphere. I will ask you some questions, for instance, to identify top nodes about related to centrality measures or ranking or communities. And the game will be to identify, well, if there are some right answers or if you have to discuss about the results. And you'll be also able to compare what you found with a real study, because researchers published on this data set, and you have the research paper in the materials as well. So let me explain a bit more about what I say about exploratory data analysis. It is a field of research rooted in information visualization, cognitive sciences, and the goal here is to help us to identify real facts in the data by using visualization techniques. And the way we use our eyes and other abilities to make emerge information. I mean, we don't really have real truth by saying, okay, this is true, this is not, or this is obvious, but we may have find some good techniques that are proved that works well if we agree on how to read the data. So in general, it is using real-time interaction is a good way to explore a network and try to have some hypotheses that pop in mind and try to identify what's going on very, very quickly, to make mistakes, to try different things so that we don't have to maybe bet about a specific result and wait for it. So in exploratory data analysis, we are focused about, okay, we know already some facts in the data, we want to confirm it visually. So your algorithm ranked your nodes, and you really want to see if it is related to a particular data structure, how the network is structured, or if there are some bias. Sometimes just by looking at the data, you find very interesting results. Otherwise, you may be interesting to check much faster if you have some intuition, some hypothesis on the data. And just by looking at the data, you may have an evidence that, okay, it's not working. Or maybe, well, I don't know, I still have continued to dig inside. And the last very interesting part is this one. Maybe you know what serendipity means? Web folks, of course. Just play around, see what's going on, and get ready to get surprised. I mean, the shape of the data, it is not something that is particularly obvious, and even if you expect some results, you may be very, very surprised by what's going on, what is apparently the shape of the whole network. Yesterday I wanted to create the whole network of view of the whole classroom when I asked you some good data. And, well, I don't think I will have the time, unfortunately, but it will be really interesting to see, hey, what is the shape of your relationships? And maybe to do this survey tomorrow and see how it has evolved. So, well, so just to summarize, I won't go deeper about the history of the field, but it was created during the 60s by a guy named John Turkey. So you will find it some books about him about exploratory data analysis, and he still continues to be an active research field. So we discovered after having created Gephi that okay, we are apparently in this kind of point of view, of approach. And what is really interesting with visual exploration is when you have evidence of a particular fact, and the picture here, it's so obvious you can't miss it, you can't avoid it. But there is a little problem with real-time exploration, that this process is totally non-linear. I mean, when you get the data, try to parse it, filtering, extracting some information, visualize it, try to refine the aesthetics or readability, and finally interacting with the data or providing a user interface for the people when you want to communicate. You will have many questions and many difficulties that will arrive. For instance, yesterday, when I started to get your papers, I realized that I missed one data, the author of each paper. So I was on this step, and so I'll bring the paper to you back to get more data. So it's generally what happens when you start to visualize the data. Maybe you see, okay, it will be very interesting to add more data, or maybe, well, I get the data not really well, so I should crawl it again, or I should modify some parameters at the beginning, or I should extract the information differently. And as long as you start to explore it, maybe you will want to have different kind of filtering and extracting different information. So creating this kind of technology is something that is particularly challenging because you can't have this tool chain to go from one step to another very simply, and after that, okay, you get the result, I'm finished. It's only the beginning. You will have many questions in your data. You will have to change the data structure, maybe. You will have to change how your visualization. What does the node means? What are the relationships means? What are the colors? Why do I use colors? Why not shapes? I mean, it really depends on what you are looking for and how you want to communicate about your findings. So in the course material, you will find the thesis of Ben Fry, who created this very, very smart chart. So his thesis called Computational Information Design. You will have more detail about the process and the challenges while dealing with data. It's a very good one, very easy to read also. But, well, let's take a very simple example to make the things very clear. Here, my research team work on peer-to-peer data. Especially, they collect data from eDonkey servers. So they studied the distribution of file size, where people exchanging files. So you have a general shape, which is decreasing here. But what is really interesting, so, well, is that on the y-axis, you have the file size, and here you have the frequency. So what is something that is we can't miss here is the different peaks. We can't miss it. But, well, by looking at the numbers, we know that the different size correspond to films exchanged because of the CDs, double CDs, etc. So just by looking at this file, and you do it every time, of course, when you have some statistics, you plot the results. It is always the same process. So there is something that is surprising here. You can't miss it. And because you have some external knowledge about the field, about the data, you will be able to draw one conclusion or one hypothesis here that, okay, things might be highly exchanged. And you may move your research in this direction to better know what's happening here. And this kind of process happens when you just get some data and, okay, I know nothing about it, but I have to ask questions, be curious. Why do I see this particular shape? Why do I see this particular behavior? And by doing so, little by little, you will become one of the experts of the field because of the data, because you have many questions. And this is why it is very, very important to be curious about the little details. For networks, it's similar, but we deal with networks. So it is only since, well, you know, there are many, many tools about analyzing and visualizing networks. One of the first one, what was really useful, was PAYEC, 1996. It's very recent. And you were able to compute statistics and to draw an image at the end. It's still used by many researchers, by the way. So what we have to do while exploring networks is first to visualize the network. Well, seems obvious, but you've seen yesterday that it's not that easy, and we have many questions about layouts, about particular choices on the visualization. Then you will want to interact in real time. This is also particularly challenging because, for instance, you will filter, change some shapes, you will interact with the data structure in real time, and it has to be responsive. So this is, for instance, the case in Gephi. We didn't optimize the size of the memory of the graph. Instead, we better optimized the update of the data structure. And so by interacting in real time, I will, for instance, taking some nodes and group them into one node or one meta node. We'll also apply different filters. We'll also see that in Gephi, we have seen some very simple filters about, okay, pruning some particular nodes, getting only the top nodes, but we may also combine filters depending on the question. So for instance, I want to see only the nodes that make the connections between 2 or 3 groups, or give me only the top nodes of each community. And you can do it visually by only drag and drop, clicking in Gephi. And also compute metrics and use the result in the visualization to add more information. It is one thing to have the network structure, but it is another one when you can use colors and other visual information to add more information and get faster in your analysis. And this is why you start to have to build a visual language. I mean, people have different backgrounds. They don't share all the same culture. They have different ways to see the information. So we have to agree at one point in the same way to read the visualization. I mean, for instance, for people, distances mean very different things and can be interpreted in different ways. So I usually receive many, many questions about what does it mean for 2 nodes to be close or to be far. Well, it really depends. But to be able to read the visualization, we have to agree on what does it mean what does the size of the node means, or the colors, or the label. Maybe we could use the curve of the edges to encode some information. For instance, if you have straight edges, in Gephi we use it to encode undirected graph. But if you have directedness, you can use the curve to have, for instance, to give the sense, the direction of the edge. So for instance, this is an edge from A to B, but not from B to A. This is one from B to A. Some people totally disagree with this kind of visual. They don't like it. They prefer to have an arrow. Well, at this point, it is a matter of efficiency in the visualization. Are you able to read the network very quickly? We created this visual because it helped us to see the hubs and the authorities. An authority, okay, you know what it is? So with this kind of edges, it is obvious. But you could imagine other ways. It's really up to you. But at one point, you have to say what you use, what the signs means in your visualization, and you have to create the legend. So this is why in Gephi we prefer to say that we create maps of networks, because we have to lay out some territories, we have to add some information, and we can add different layers about what's going on from some specific subgroups or the others, and we have to add a legend, title, how we created this network. It is very, very, very important also that you make explicit all the processes that were, I mean, all this chain. You have to say what you did at every time to get this to get a visual, because otherwise people could imagine many, many things. It's totally crazy. So finally, what are we looking for by visualizing networks? Some people say that we should emphasize a just simple small truth. I mean, this is the same network, but on the left you have no particular tuning. I mean, it's just a layout. And on the right you have unconnected or few unconnected nodes that are very, very small, and and so here on this image you can emphasize some different groups and the linkage structure much more better. So it is much easier to read here than here. So you can use Gephi also to make the visual clearer. And so you can use it as an illustration in your results, in your discourse, as an argument. Many people really like to use images as, okay, this is a truth. But I disagree with it, because it's just some data manipulated and plotted. And you have many ways, many biases in these visuals. So what I prefer to say is that we are looking for some kind of orderness in the data. I mean, complex networks are interesting to study when they are not totally, the structure is not totally obvious, where it is so clear that, okay, there is almost no point to study them. And on the other range, you have, okay, everything is random. You have seen the random model, random graphs that are used as null model. So here, okay, it is random, I have nothing to say more. But between the two, it is very, very, very interesting. Imagine that you can make varying 3 different cursors simultaneously on your data, and you want to extract some information at different levels. So for instance, micro levels, how people are connected to each other, to macro level, what is economic structure, how do cities or states get organized through the individual actions. You may want to use different dimensions in your data. It could be only the person, but maybe also some attributes, gender, age, profession, etc. And you also want to see how it evolves over time. And this is a very, very tough problem. I mean, for the visualization, we only start to have good tools to visualize dynamic networks. And this is an active research field for information visualization researchers about how to visualize an evolving network efficiently, to see the trajectories of individual nodes or the merging and disappearing of groups. Not easy at all. So when we apply different zoom in the data, we may want to ask these different questions. If you look at the global level, you may have to ask what is a graph fully connected? What is its density? Is it centralized at one point, or is it decentralized? At the local level, we'll focus on the organization of groups, of communities. You may want to find some bridges between communities. Who makes the link between the groups? If there exist centers and periphery in your data, something is not obvious. And at the individual level, much more focused by sociologists, you will have some good statistical techniques to identify central nodes or top-ranking nodes, or evaluate the distances between elements. Maybe just to look at the neighborhood of a particular element. What is the local context of a particular element? Or maybe try to find it is related to the geographical location. We have seen in the previous talk that it may be very useful for social networks, strong correlations, and also having other kind of ranking systems. About dimension, well, we can have a network of individuals, but maybe individuals and related keywords on website or everything else, or consumers, products, etc. You can have very different way to create a network based on multidimensional data. So you may want to focus on the social part of, okay, who is who and who is with whom? What are the communities? Do there exist brokers between those communities? And what is really trendy in the industry is a problem of influence. When you have an action on the network, do the action has consequences in this network? Very difficult question. And power also. Another good question is what we call homophily, which is basically, do people sharing the same attribute tend to group together? Do people who like the same films tend to stay together? Do people who study the same the computer science, etc., tend to stay together? Well, this is also a good question. You may also want to mix with the topics exchange, particularly on the web. So you could create a web graph based on the hyperlinks, based on the topical proximities, based on, well, anything else you want. And this is particularly important to identify the topics. And I will give you an example about studying how science evolves. What are the hot topics? and how to react. And also you have some geographic phenomena. So, well, I have not so much to say about the timeline. Tomorrow we'll see what are the abilities in Gephi to deal with dynamic networks, with timeline, dynamic statistics, animation. One practical use case here. In France, we try to foster the innovation by giving some money to local clusters. The state will give some money to an organization which will distribute it between laboratories and companies to work on same projects, which are for industry or for the theory. And in a specific region here, we mapped this innovation center, and the decision makers really wanted to have a global dashboard about the activity in their innovation center. Who is working with whom? On what topics? Do they have particular regional preferences? So we had this project when from textual reports we extracted the different topics and we linked them to the different actors, and we mapped the actors based on their geographical location. It really helped, apparently, for the decision makers to identify the good players and bad players in this game. So they use it to prove what the feelings they have about some specific actors who prefer to take the money and not sharing with the others. It's interesting. Well, another one, but I already showed you. Well, when you present this kind of map, people will tend to think that, okay, this is the reality, this is the truth, this is a scientific fact. I mean, you are very rigorous, you can present the different sequences, and after that you can have some very good overview about what's going on. But it is strange because it is a series of choice, many choice. First one, what is a corpus? What kind of data will we select to work on this corpus? What are the algorithms to create this network? Do we apply some thresholds to cut the data or to clean the data? Sometimes it has very strong implications. We also had a series of graphical operations, colors, size, etc., which will mean very different things. And something also that you have to really keep in mind when you see a visualization. What is the goal? What is the point of presenting this kind of visual? Well, you can emphasize different facts on the network depending on what you want to show. And there are also some companies who are interested in presenting good results, even if you have to cheat to modify the data, just to say that, just to use a visualization because it's like the truth. And okay, I won't dig inside the text and the details, and so they try to cheat you. So be careful about that. It's not only related to networks, but you see in the media regularly some simple charts that has just, well, if you, for instance, you know that it is a good practice to start the y-axis at 0. Because when you start only on the minimum or on the maximum, you will emphasize something totally different. For instance, you will see, imagine that you have a chart that will go this way. If it's not 0 here, the discrepancy from the range could be very, very very tiny. But because of the visual, it is still like a dramatic decrease. And wow, it's something is happening there. Well, it is so easy to cheat with visualization. Also, by looking at a specific time period, I mean, what is a trend during the last month? It may be, okay, very good, or the economy becomes very catastrophic. But if we look at a larger time period, it may be just normal variations and something not particularly dangerous. So you really have to understand what was the process. Be careful about the little details on the legend and understand what was the goal of this company, of this particular individual who presented this result. Not to be foolish. And also, it may be also useful to check about the context. See, okay, if I have some other data, what does it change? For networks, it's particularly important. I mean, if you change less than 5% of the nodes and the edges, you could have a totally different structure. Remove only the top 3 most connected nodes, the structure could be totally different. So there is a real problem by dealing with collected data and experiments that you can't reproduce. For instance, researchers who provide results about social networks, some data that you can't access because the data evolve. Maybe they had some pruning or cleaning operations that will have strong impact on the results. Or when crawling the web, if you crawl it again, you will have also different results. And depending on the technology, you will get different websites, different links, depending on when you started also. So, another point what is particularly difficult is to identify when network is useful. In general, well, some decades ago, researchers dealt with very small networks, 50 nodes, 60 nodes, 100 nodes. Wow, big deal. But today, we prefer to say that it's just, okay, you have a list of nodes and some edges as a bonus in them. I mean, the structure of the network is not really informative on so small networks. Sometimes, most of the time, it's particularly obvious, or you won't have more information. But if you have qualitative data, if you have information on particular elements, well, it's a point when it starts to be really interesting. And on the second scale, up to 1,000 nodes, the structure is still really obvious to see. I mean, now we have tools like Gephi and other good softwares who are able to show you the structure very easily. So here the question is more about how can we understand the structure because of the attributes. And this is, for instance, okay, those bloggers tend to make links to other bloggers. We may also want to focus on a particular element. I mean, you know something about this person. You want to know where he is in the network, what are his direct connections. But well, I won't go too much further. The problem is that by increasing the size of the network, the structures start to be hard to read, and depending on the layout and the operations, you will find very different shapes, very different patterns. So here, it is more about how we can explain some particular attribute, some particular value based on the structure. And as long as we have more and more data, we tend to have some lower expectations because it quickly starts to be very difficult. At one point, people just want to see if there are some communities in their large data. Wanted to show you something. No, not this one. Okay, forgot. Next. Okay, some practical applications now. Well, you know that Gephi is used by a company called Quid in San Francisco. What they do is to identify key trends in a market for big companies or governments to identify, okay, a use case. I have a company, I want to implement, to make business in this country, what's going on? Or I'm working on this particular technology, I want to better know what is the current trend in research and what should I expect in the next 5 years. So this company use Gephi for their business. What they do, as Gephi is open source, they remove the user interface, they implemented their own user interface dedicated for their own analysis. And it helps them to identify, well, they process a large amount of patents, research publications, web documents. They apply some data mining on it to extract clusters, to label clusters. And after that, they visualize a network of clusters to help them identify what is the state of research and the market. Oh yes, I have to show it something after. Another one for medicine here. In the US, there is a large database about drugs who fail. I mean, when you take 2 or 3 drugs at the same time, sometimes the combination may be not very good at all for your body. And so they report this kind of problem in a database. And they recently created this the network of correlations between problematic drugs. I mean, the nodes are the drugs, and the links exist when 2 drugs taken at the same time were reported to be problematic. And it appeared that they were able to identify clusters. And it is very, very interesting for the pharmaceutical industry to see it, because it is a shortcut for them to answer. Well, they have this question: why do we have clusters? Why this group of drugs are problematic? Or maybe they know that this drug and this one are given simultaneously and they are not problematic. But they are in 2 different clusters, no other link. What's going on? There may be new interesting questions for their research, and maybe they will be able to identify, well, to identify the reason behind it. So a good way to explore a data set and extract meaningful questions in it. Well, we have already seen for innovation landscape. Another use case, Facebook games. Well, I know a little company in France where they use also automatic clustering and visualization with Gephi to identify multiple accounts on their games. So that's a nice application too. More seriously, on the US, you know that Twitter is hugely used to convey political messages, information, or misinformation. It is very important for these people to control what's going on, what is said about a political leader. And you have bots on Twitter who deliver false information. And if people don't check if this is a real information on something that is called truthy, so a false information that looks like the truth, they will retweet and misinformation will spread. It could be really dangerous for this politics, but it could be also applied for terrorism. I mean, you are in war against this country. If you make big troubles in their information system, in the media, on Twitter, and the population get false information, it could be really, really dangerous. Or imagine you can spread the news that there are some virus delivered in the city and people get easily contaminated. The population could become totally crazy very fast. So the government must check what's going on and also to identify, maybe to prevent this kind of scenario to happen. So at the Indiana University, they created this project called Truthy at another complex networks laboratory. I don't have exactly a CNET, I don't have exactly the name, but they monitor Twitter in real time. They apply data mining, machine learning techniques, and they try to detect the suspicious diffusion of information based on the shape of the network. So for instance, here you have, well, one meme on information started from this node to all of these others. Sometimes, well, the structure can be really different. And based on this information and on some information on the dynamics of the diffusion, they can find relevant patterns and automatically label false account, false information. A very good project. Are you on LinkedIn? Okay, do you know the experiment called InMaps? So check in on Google. You will be able to log in and to create your own professional network. So this is also a good way to have more context about your contacts and the relationships between your contacts. Something that you can't really have with a regular LinkedIn account. And behind this experiment, the short story that the main developer of Gephi get hired by LinkedIn, and he started this project in the company to be able for every LinkedIn user to visualize their own networks. A very nice project. They had to play with a cluster of 400 machines. He loved it. And what they do behind, they apply a community detection algorithm to have the colors, and the application lets you label the different groups. So maybe you will be able to make sense about it. Another one. about ontology database. Here, researchers in biology have this database of biological terms. There are 4 or 5 big dictionaries about it, and they made this application to query this database and retrieve the subgraph of ontologies linked together, and it helps them to identify problems in the database, or just to have some new ideas about, okay, I know this term, but maybe I could check this one or this one, which is close or similar, or it is somehow related. Yeah. Another one. Well, you know about Wikileaks? Of course. So, I know a journalist from The Guardian who took the whole archive about the Iraq war logs, excuse me. And he applied some co-occurrence analysis. So between two documents are linked if they share the same terms, the same vocabulary, or are enough similar to be linked, and created some and clustered this document. And he used a visualization to help journalists to dig inside this large archive of documents, because they can't read any message. It's too long. So it is a way for them to have a shortcut again to the data. So for instance, he was able to identify information related to police, to injuries, to female people, etc. So this is also a way to make a large data set available and useful for other people. Well, that's okay for it. About science, I wanted to show you something. Yeah, this one. A science map. So let me explain a bit more about what you see here. So researchers in the US are very interested in how their science evolves and what are the key strengths and weaknesses of their nation about science. And they want to know their position against other different countries. So what they do, it is also helpful to better identify how to get better organized in research in general, or how we could rank researchers based on different, on different parameters, not only the number of publications, for instance. We could have more ideas about how to just recognize a good researcher. So what they do here to identify what's going on in science in general is that they applied co-occurrence analysis on a large number of papers. And they applied a clustering also to identify a group of papers and to label the different groups on physics, chemistry, and different subfields. So they laid out this kind of this large map, which is not really readable here. Can't see the label. I'm sorry, I don't have a better one. But what is interesting here is that you can identify groups of, here it is, cognitive science. There is something about physics, something else. Quantum physics here. Organic systems, etc. So you have different groups that emerge, and how people who publish in a specific area will also get some collaborations with other related areas. And on top of that, they added a layer with the different colors to identify where do the Americans do the best, do they contribute the most. And so they are able to see that they are very good in all these areas, very present, there's one too, but they miss good research in these particular ones. And what is interesting with this kind of technique is that you can apply another layout for another country. And maybe you will see, for instance, that Germany worked on solar panel since many years, and they are one of the best in the world in it. So it is also a way for policymakers to understand what do we do in science at a very large scale, and how should we distribute the money? What will be the field to support in the next decade? So network maps are also a tool for people to make decisions. Okay, still have half an hour. So we have half an hour now. I will explain you some differences on about the layouts, because you have many different layouts, and there will be new layouts created in the future. Well, so in Gephi we implement a very few layouts. I mean, you have Reingold because it was of the legacy layout. You have our homebrew layouts, the Force Atlas. You have the OpenORD for very large network, and after that, well, you have one or two, but that's all. Because we don't want for the user to just, well, I don't know what to choose. There is everything, every layout I can get. What's going on? So we prefer to let you better understand what's going on by using one layout or another layout, so that you can draw very good conclusions about what you see. But, well, sometimes I will just... So this tutorial is available on the Gephi website, and you have also it on the material. So if you want, in the practical session, you can try to follow this tutorial, and if you have questions, I am here with you, and we can discuss very freely. So, well, you can add some other layouts in Gephi by installing plugins in the Tools menu. We'll see some of them in this document. So, but very quickly, yes. This one, and this one are the same network, same data. But here, using OpenORD, the fact is that this layout will emphasize the different groups. So you will see this group, this group, this group. They are very far between each other. On the contrary, by using Force Atlas, groups will be much closer, and you will be able to easily read the connections between the different groups and different elements, something that is much more difficult with this layout. And by using another new layout called the radial axis layout, you will see that you will be able to easily check what are the top nodes according to a specific parameter, and you will still be able to see the connections between the different nodes. So it's kind of, okay, I have the nodes and edges in bonus, and I can still read the connections. And you have also this layout, geo layout. If you have geographical coordinates, latitude and longitude for each node, you will be able to map it on a geographical map. So, well, how to choose a layout? It depends on what you want to see. By default, I use Force Atlas. Very practical for most of the case. But it's better to see complementarities with it. OpenWorld is better for division between groups. Radial axis layout, better for to see a ranking between nodes. So in Gephi, you will also have some utility layouts to make some adjustments. So for instance, there is a label adjust layout, which is a way to get non-overlapping labels. Something very, very useful. I mean, during 2 years, we didn't have this algorithm, and so to finish the map, we moved each node one by one, just to see all the labels very, very clearly. And when we decided to implement it, wow, we gained some couple of hours each time we had to make a map. There is also the overlap layout. You choose either one of these layouts, and then after you apply the overlap, and it will make the nodes not to overlap. A good one also. And you can also expand and contract the position of the nodes. Sometimes it's useful. So well, Force Atlas. We designed it to render, in particular, scale-free networks or small world networks. I mean, I've talked about identifying groups, communities, several times until then. It is because on this type of graph, you will find this kind of structure. And if you use another layout, so for instance, of Frosterman-Reingold, I mean, this one, it is much harder to identify the groups. On this small network, well, you still can identify the groups, but it's much difficult than having this. Do you agree? Good. So we try to continue to make some improvements. This algorithm is quite low. I mean, quadratic complexity. It's good until 10,000 nodes. After that, it will take a long time. I will skip the different parameters, but you can use this tutorial after to understand what's going on for each one. Well, Frosterman-Reingold, a very old one, and not very good also. But he has a very interesting system of way to lay out. I mean, it is the simulation of an electrical system, or when you try to minimize the energy of the model, and it was one of the first to create a good visual. Another one available in Gephi, a very fast algorithm. Force Atlas and Frosterman doesn't stop. I mean, you can let it run forever if you want, and you have to decide when the visualization is good enough for you, quite stable enough, and then you stop. Of course, well, we decided to make this choice to better help the user to identify, okay, this is my visualization, and I will stop, and I have to be aware that it is just, okay, I run an algorithm, and it's just, oh, I get the result, I get the truth. It is not the case. You have to make the choice. You have to understand that all the visuals are relative, and you have to read it very carefully. So for this one, it has a stopping condition, and it is designed to be fast. I mean, with a lower complexity, and it is better to have large networks on it. It is quite good to identify groups, for instance, but for some data sets, it's not very interesting. I will skip, but for this kind of algorithm, you will have some optimization technique to go faster. If you are interested in about graph coarsening, or how to lay out a graph with a multi-level technique by identify to summarize the network to better spatialize, and after that lay out every node. This kind of technique, you will find some paper, the paper very easily. It's a technique that could be useful maybe in other context. Yeah, OpenORD. Also a very good layout for very, very large networks. I mean, you can easily scale. It is very fast. So what's the point here is that the algorithm will try to identify the communities, basically, and will cut the long-distance edges. So the communities will tend to get separated very easily, and after that, he will try to lay out again nicely more. This is a particular technique. I don't know much more about it. I've not coded it, so you can find the paper also very easily. Force Atlas 2. Well, we improved the original layout here by adding also some approximation techniques so that it can scale much easier, and we created this algorithm to still be able to see easily the different groups, and having a nice way to see scale-free networks. It's quite a bit different, but it works very well. On available plugins, you will find also some other layouts. I mean, this one seems obvious, circular layout, but very efficient to order the different nodes according to an attribute and see the connections. It's also very easy to read from one node. Quite useful. Another one is an extension of the circular layout where you will group some nodes according to a parameter. So for instance, do they belong to the same community? Do they share the same attributes? And so all of these nodes share a same property, the one you define. And you will still be able to read the links. What is interesting, for instance, is that you group them here with one attribute. So for instance, two people are from the same city. And you also apply a community detection algorithm to color the nodes. And you try to see if there is a correlation, if all the nodes have the same color or not. So also a fast way to find correlations visually. Yes? Is also? Yes, I mean at the beginning of the software, the father of Gephi worked with sociologists. He was also a he was not a computer science engineer. He was. We had this urbanism discipline, and so he's from design and urbanism, but he's a total nerd, and he loved programming. So he went to this research laboratory and created the prototype of Gephi. He thought about many good principles that we upon what we built Gephi. So, for instance, he created the 3D engine, the basics that is now running in Gephi. He invented also the way that, okay, we should not stop automatically a layout, and we should let the user to see how the layout is running. If you use other softwares, for instance, Cytoscape or Guess, you click on the layout and you wait until it finishes. So you don't really have a sense of what's going on. And this was one of the most problematic thing for sociologists, because, okay, they are very aware that even if you are able to describe what should do the algorithm, well, for some specific cases, it doesn't work very well, or you don't really easily have a sense of what's going on if you don't want to read the paper and you don't really know what is computation and some sort of that. So he also created the Force Atlas, just to help also to read the networks. Because the other layouts provide poor results for the visual exploration. I mean, it is difficult to evaluate what is a good layout, what is the quality of layout, because it is almost totally subjective. You will find, for instance, surveys about layout that we create layout that should be visually appealing, that precisely scientifically defined. Visually appealing, what does it mean? So it's really up to how people are able to read a network and read the structure and to find information or hypotheses about the structure that are interesting. So there are still many research about layouts and how we can evaluate the efficiency of a layout. Last year, I participated in a contest, a visual contest in Dublin. The research team here invited the team behind Gephi, behind Tulip, behind Cytoscape, behind Payek, other softwares, and the contest was very simple. They gave us a Facebook dataset about university alumni in the US, and by using our own tool, we had roughly 1 hour to identify good questions, good hypotheses that were also verified by the researchers because they were able to they were about to publish a paper about this data. And it is really interesting because with some tool we were able to identify strong correlations between, for instance, do students who share the same, who are in the same dorm, tend to be close together, or is it more a matter of year? Is it more a matter of where do they are from? Not obvious at all, and the question, the answer vary from the different datasets. We had 3 datasets, so this is a way where, okay, the expert of the tool were able to draw interesting hypotheses that were statistically verified by the research team. So, okay, good question. Good shortcut. You can go faster in your research. That's okay. But we still don't know what happens when somebody who is not used to see a network reacts. What does it find? How does it think? I'm in contact with many people. For Gephi, I'm the community manager. I try to interact to understand what people need, to go to conferences, to meet them, and also to check what people are saying about Gephi and networks on the web. And sometimes it's really striking. I will show you something. You will understand what I mean. Let's go. I have to connect. Okay, good. Well, I have hard times to improve my Russian this way. So, for the story, there is a researcher in Italy who created an API in Gephi to receive network events in real time. It is called the Graph Streaming API, and I will show you how it works tomorrow. It's very interesting to monitor, for instance, a particular hashtag. So, during the Egyptian revolution, they collected the tweets and retweets about the hashtag Gen25, which was mostly used by people from the riots to get organized and share information. So he collected the data and created a video in real time about what's going on. The video is particularly, well, it makes something to see this visual. So, and you will understand why. So there is a link when there is a retweet. And so the nodes are Twitter accounts. Yes. Yes, yes. Do you know how much time this video was watched on YouTube? More than 100,000 times. People loved it. But why? It's not a good visualization of a network. It is totally disconnected. I see you have, so here there is a zoomable visualization. I have this node connected to many others. If I go, well, here I have also this other account. Well, but people loved it. They talked about it. Some people created mashups of the video with, you know, classic music or something particularly charged, you know. Do you know why? So, what did the people really see behind this image? They see their people. They see the Egyptian people on Place Tahrir meeting at this place, and it was a metaphor about what's going on, because the nodes corresponds to real people, and it makes something very particularly strong for many people to have this visual. How what's happening on Twitter is so closely related or show something that is emotionally charged about what's going on in real life. That's what people see on it. So the visualization can sometimes be also very powerful to transmit an idea, to transmit something, something strong. And you have to use it very carefully, because people will see things that are totally different. Well, people identify some brain, or they imagine some galaxy or otherwise. So well, what do you want? Why do I started it? Oh, did you go to see a movie Galaxy? That one. Galaxies. This is another use case where network visualization is used on the web. And it is used not only for the show up, but also to better have novel ideas about network structures. So here, well, for instance, I can see the network of Pulp Fiction. Wow. And for each node, well, I have some information on the network. And my screen is very small. Well, I could let some comments. It's sometimes very funny to see how what people say about it. What do they think? And some people analyze this structure. I mean, they may be totally different depending on the writers. Here, the links exist when two characters are present in the same scene. And so it is mostly research in statistics, but visualization is also helpful to get more information. Do I have some comparison? No, too bad. Okay. So I will finish here with it. During the practical session, we'll work more closely about a specific data set, the Irish blogosphere, and we'll also try to identify what are the top bloggers, how could we identify some maybe some clusters about food, about fashion, just by visualizing the network. The researchers who release the data set use both visualization and statistics and tried some clustering algorithms. So it will be interesting to see, okay, maybe are you able to identify the same things as these researchers? Maybe we'll be able to see something different. Well, it will be also a good use case to better learn about using layouts and some specific features of Gephi. And tomorrow, we'll see much better about dynamic networks. How can we encode them? How can we visualize them? Apply some statistics. And well, how to publish some results also on the web. Not very easy until now. And also, if you want to code your own algorithm in Gephi or use Gephi as a library, it's also possible. So we'll see how to code with the Gephi platform tomorrow. Thank you.